One way that programmers commonly want to access elements of sequences is with indexing. In Python, lists and other sequences can be indexed with the square bracket operator. You write the name of the list, then the index that you want to access in square brackets. The indices of a list start at 0, so the first element of this list is mylist square bracket 0. Indexing is often read as @, so many programmers would call this mylist at 0. The next element is mylist at 1, then mylist at 2, and mylist at 3. So now if we wanted to execute this next line of code, a equals mylist at 1, we would look in mylist, pick the element at index 1, which is 12, and put it in a box for a. You can also use indexing on the left side of an assignment statement to change a particular element. Our next line of code assigns 42 to mylist at 3. So we would find the location for mylist at 3 and change it to 42. Now that you have seen indexing a single element, we want to talk about a nice feature of Python, slicing. Slicing lets you access a range of elements all at once. The syntax for it looks like indexing, except that instead of a single numerical expression inside the square brackets, you put a start, a colon, and an end. For example, here we have a list with many numbers. If you were to slice it with list 1 at 4 to 8, you would be talking about the range of elements from mylist at 4 to mylist at 8. Note that this range includes the start but excludes the end. So you would be specifically referencing the range of elements highlighted here in green. Assigning this slice to list 2 would copy those elements to a new list in the heap and point list 2 at that list. When you use slicing, you can also leave the start portion blank, which means to start at the first element of the list, the same as if you wrote 0 there. Here you can see what happens when you slice with the start being blank and an end of 8. Likewise, you can leave the end position blank, which means to include everything through the end of the list. Here you can see what happens when you slice a list with a start of 4 and the end being blank. If you leave both start and end blank, your slice references the entire list, so you would copy the whole thing. You can also use a slice on the left side of an assignment statement. This use of slicing will replace the entire range of elements with the list that is on the right side of the equals. Here we are about to replace elements 2 to 7 with the list 2, 4, 1. Notice that the range from 2 to 7 has 5 elements, but the list 2, 4, 1 only has 3 elements. That is totally fine. This operation will reduce the size of the list by 2 elements, resulting in the list that you see here. We removed all 5 of the elements in the range from 2 to 7 and put in 2, 4, 1 in their place. While we are talking about indexing lists, it is worth mentioning that indexing and loops often go together. While there are many times in Python that you can just write a for x in mylist style loop, there are other times when you need to access the elements of the list in other ways. For example, if we want to take the difference between consecutive elements, square that difference, and sum those squares, then indexing works nicely. We can have I count over the indices of all but the last element, and then index at I to get that element and at I plus 1 to get the next element.